Imagine if when your mobile phone gets too old or breaks, it could be taken care of by nature because it was made entirely from plants and would therefore decompose and nourish something new. That is precisely what Dr. Ergang Wang, professor of chemistry at Chalmers University of Technology, is working to develop. His vision? To create a sustainable cycle of organic electronics where old devices can biodegrade into the soil. And the broken down components can be reused to manufacture new electronics.
In the future, I hope our research can really make an impact on the world. Now I see the electronic waste is really a big problem. We are producing more and more electronic waste.
Every year, 70 million tons of electronic waste is produced that cannot be recycled. Instead, it ends up in landfills like here in Agbogbloshi in Ghana. Here, the electronics are burned without any thought for either the environment or human health. A grimly ironic example of electronics that can end up here are solar cells. Because in spite of being a green energy source, there is currently no good way to recycle solar cells when they are out of commission. But Ergang Wang wants to change this.
The problem with silicon solar cell is that they cannot be recycled. With our research, I hope we can change it.
And it was this research in organic solar cells that took Ergang all the way from China to Gothenburg.
Okay. Yeah, I think if we make a polymer something like this, it will redshift the absorption. Then we can further improve the efficiency, right? Yeah.
Ergang grew up in the city of Zhumadian in central China, and the dream of one day becoming a scientist was awakened in him early.
Since I was a child in junior school, my teacher told me it would be great to be a scientist because as a scientist, you can invent new things. Since then, becoming a scientist is my dream.
Today, this dream has become a reality after a lot of hard work.
My teacher also told me in order to be a scientist, you have to study really hard.
After receiving his PhD, Ergang heard about exciting research on solar cells at Chalmers. He left China for Sweden. But once here, he discovered that success as a researcher not only takes hard work, but perhaps even more importantly, creativity.
When I moved to Sweden as a postdoc, I tried to keep my working habit. I still work very hard in the lab. And then one day, my postdoc supervisor told me, don't work too hard in the lab. When I heard that, I was shocked. I feel, how come a professor told you don't work too hard? And then I start to think about what the professor told me. I realized, maybe as a researcher, you have to be more creative.
Ergang took the professor's advice and realized that new ideas can come anywhere. But he's still not quite down to an 8-hour workday yet. And it's here in the lab that the flashes of genius transform into reality.
When I have a really good idea, and then I go to the lab to start to do experiments.
One of the ideas that has now come to light is this solar cell leaf.
So polymer solar cells has a lot of advantage as compared to silicon solar cells. For example, it can be lightweight, semi-transparent, which means you can even put it on the window. And you can also make very different shapes. For example, this is the leaves that you can make. It looks like the real leaves, but you can use it to generate electricity.
The leaf is made up of polymers, i.e. long molecular chains. The properties of these polymers enable the material to also function as a so-called semiconductor, which is crucial for the solar cell to be able to convert photons or light particles into electricity. And semiconductors are not just a central component for solar cells, but for virtually all electronics. This gives Ergang the opportunity to take all of this a step further. By obtaining polymers from nature, he hopes to be able to manufacture electronics that are also biodegradable. One example of this is a so-called LEC lamp, which Ergang wants to manufacture using chlorophyll taken from spinach leaves. It will function as a solar panel, but in reverse. Instead of generating electricity, it will generate light.
We can extract the chlorophyll from spinach that you can buy from a supermarket. We are going to use it to make a biodegradable device.
Ergang's vision for the future is that the electronics we use in our daily lives will not have to end up in a landfill in Ghana when they have completed their service life. Instead, they can become part of a sustainable cycle of electronics that can be recycled and biodegraded. And one day, we might even be able to produce electronics that we can eat.
It can help to solve the food shortage and also protect our environment.